Several of you mentioned having difficulty with lesson 3.2, which deals with variation. So I want to kind of walk through it and walk through some examples. There were three different types of variation that's mentioned in that lesson. You have direct variation, inverse variation, and then joint variation. And honestly, it may not be as obvious in the lessons, but really they're all three a formula. The formulas vary. It's usually very obvious to know which one you have because it is clearly stated in the question. So I want to deal with direct variation first. The formula is y equals k times x. K is kind of your rate of change, your unit rate. It kind of depends on the verbiage that's used by the textbook author. So an example, and again, as I mentioned, notice it says in this particular problem, y varies directly as the cube of x. Okay, so it very clearly in the question states that you're doing a direct variation or that it varies directly. And typically the first sentence in these questions will give you kind of the formula that you need to use. And so this one, if we translate from the words to the symbols, that first sentence says y varies directly as the cube of x. So you have y equals, you have your constant to the cube of x, so it becomes x cubed. So your generic formula is y equals k times x cubed. Then typically the second sentence is going to give you some information that you can fill in. It says if y is 20 when x is 2, find y when x is 4. This if part here gives you enough information that you can determine your rate of change or your unit rate. Okay, so we would have when y is 20, so I'm substituting 20 in place of y, equals, I don't know k, and I know that x is 2, but it's 2 cubed. So I get kind of this basic algebra equation that 20 equals k times 2 cubed. So doing the math, 2 cubed is 8, so I have k times 8. I'm trying to solve for k, so I'm going to divide both sides by 8, and I end up with a value of 2.5. So my rate of change, so then now I know that rate of change, and I can come back up here to my formula and write y equals 2.5 times x cubed. And so then the final step is to find y when x is 4. So I have y equals 2.5 times 4 cubed. Again, it's just a straight, flat out substitution. So then we do the math. We would have 2.5 times 4 cubed, which is 64. So if we do 2.5 times 64, you may want to use your calculator, we get that y equals 160. So that would be my answer. Okay, so everything is laid out for you in the problem. You just have to take your time and walk it through. The piece that you probably need to know is kind of how to set the direct variation up. And it's always set up y equals k times x in the process. Okay, then let's go on to inverse variation. What changes with inverse variation is the kind of the generic formula. It becomes y equals k divided by x. And again, it's usually very obvious that you're doing an inverse variation because, as we've talked about already, it tells you in the problem that it varies inversely. In this case, it just says y varies inversely as x. And again, that's the clue of which formula, if you will, you need to use. And so again, we translate those words into symbols. So I would have y varies inversely as just plain old x. So I have y equals k over x. And again, what you have in the problem, it tells you the if y equals 4 when x is 8, using that information, I can find my constant rate of change, or my unit rate. I can find k. So I would have 4 equals k divided by 8. And then I need to solve that equation for k. So I would multiply both sides by 8. So I have 32 equals k. And then again, at that point, you come back to your formula, if you will. So we have y equals 32 divided by k. And then I should be able to find y using the second piece, because it says find y when x is 16. Again, that becomes a plug and a chug. And I noticed I've got a little error here. I put k instead of x. I apologize for that. Sorry. So we would have y equals 32 divided by 16. So y is 2. There's your answer. Now, when you get into the idea of joint variation basically involves more than just an x and a y. It involves maybe 3 variables or 4 variables. And the formula would be something like y equals k times x times z. You could have more letters than that depending upon how many variables you have. But again, one of our benefits is that it does clearly tell us in the problem that it varies jointly. And again, it gives you what it varies jointly with. Again, this one just reads, again, translating from words to symbols, we would have y varies jointly times our constant k as x, z, and w. So we have x times z times w. I have really a total of 4 variables because you have x, z, w, and then y. And again, excuse me, guys, it's just straight out plug and chug, because the if, it says if x equals 2, z equals 1, w is 12, then y is 72. Okay, so again, we get the values, and using those values, we're able to find k. So let's say I'm going to plug and chug. Y is 72, k, x is 2, z is 1, w is 12. So if I do the math, I have 72 equals k. 2 times 1 is 2 times 12 is 24. So I have k times 24. I'm trying to solve for k. So I'm going to divide both sides by 24. So k is 3. Again, going back to the original formula, then I would have y equals 3 times x times z times w. And then from there, using, again, plugging and chugging, when x is 1, z is 2, and w is 3, I can find y. So I have y equals 3, which is k, times 1 for x, 2 for z, and 3 for w. So I would have y equals 3 times 1 is 3, times 2 is 6, times 3 is 18. So y equals 18. So I hope you find those examples of variation helpful as you are studying and preparing for your midterm exam.